Aloha Friday,
Aloha.
everyone. I wore my University of Hawaii hat for you guys.
Oh, great.
Great. Well, why don't we get started? I'll do a brief intro, Dr. Fox, and then I'll actually let me give you screen sharing before we start. I'm going to make you a co-host, which should allow you to screen share. Okay, so thanks everyone for joining. We have a very exciting speaker today, Dr. Fox from UCSD and the Native Biodata Consortium, who's going to talk to us today about disrupting the indigenous DNA supply chain. I'll introduce Dr. Fox in a second, but just really quickly, welcome to the first AI Precision Health Institute Affinity Group meeting of the year, where our goal is to hear from leaders in the field and discuss certain trends related to AI in healthcare. We're really promoting an interdisciplinary group discussion. So we're bringing together researchers from computer science, engineering, nutrition, epidemiology, radiology, genomics, bioinformatics, and a variety of other research areas together with clinicians as well as advocates to be able to foster collaborative interactions that could ultimately help various applications in medicine using computational techniques. So the format is usually a talk and then an interactive Q&A session. So while Dr. Fox is giving his talk, please queue up some questions. We have some upcoming speakers in the next few months as well. So we tend to meet on the first Friday of every month at 9 a.m. Hawaii time. And the list of speakers is kept up to date on this link. We are hosted by a few institutions, so that includes the UH Cancer Center, the Artificial Intelligence Precision Health Institute, the Hawaii Data Science Institute, and that allows us, by being hosted by a variety of institutions to foster this interdisciplinary collaborative discussion. So I always like to start with a paper of the month. And the paper of the month I like to start with it was published by Dr. Fox in Science. It's an editorial in light of the wildfires in Maui and discusses implications for sustainability and tourism. So I highly recommend that you read that paper. So without further ado, I'd like to introduce Dr. Fox, who is the co-founder of the Native Biodata Consortium and a professor at UCSD, where he co-directs the Indigenous Futures Institute. And he has extensive experience in designing and engineering genome sequencing and editing technologies, focusing on the connection between raw data and the value of the data. So without further ado, Dr. Fox, take it away.
All right. Aloha kako, everybody. Good
Aloha.
morning. Aloha kakahiaka. And it is Friday. So let's not forget about that. How many trainees do we have on here? Many? Nobody? Everybody's just black screened? That's okay.
Let's see.
All
We do have the
right.
reactions on, so you can give a thumbs up or something if y'all want to answer questions like that.
Yeah, if you're a student, okay, good. Yeah, awesome. I kind of have a special special series of slides for you guys today, and we'll be talking about a number of ideas. And it's so awesome to see that there is just a thriving artificial intelligence and machine intelligence community in Hawaii. And I hope it continues to grow in some amazing directions that directly impact precision medicine. And so now I'm going to share my screen. And you guys tell me if it looks clear. Does that look clear? Looks clear. Looks good.
Great.
Okay.
Yep.
All right. So let's get it going here. All right. So I have titled this the Disrupting the Indigenous DNA Supply Chain. And a few things about me. I'm at UCSD in La Jolla, California, which importantly is ranked #1 by Surfer Magazine every year. I want everyone to know that, even more than UH, which is strange.
Come on. I don't
I know.
believe that.
I know, but I just wanted to explain that it's an interesting place to work because we have like a thriving community of people that are focused on oceanography, but it's also a really interesting ecosystem of people that are focused on genome sequencing and editing technologies broadly. And so if anyone finds themselves in the La Jolla area, give me a ring, and I'm happy to show you around and show you some of the things that we're building there. We started the Indigenous Futures Institute. A lot of this was inspired by things that happen every day in Hawaii. We have a huge focus on Indigenous futurism and using emerging tools to really enhance and empower our communities, specifically Kanaka Maoli communities, but a lot of our co-partners and the partnerships we have are with the Kumeyaay Nation, Navajo Nation. One of our faculty members is in UPIAC, so it's a really cool, different direction. And it's not just medicine, it's a lot of different directions that we're kind of taking our work. So please check it out. We're also hiring. We have 12 FTEs for different ranks. So these are totally different directions. That could be anything from assistant professor to full-on tenure track positions. And it's an interdisciplinary cluster hire focusing on a number of different things. So please check that out below. Kind of shameless plug here. But for me as a Hawaiian person, focusing on Indigenous futurism and kind of understanding what this means is we come from a rich heritage and culture of people that have been utilizing emerging technologies and innovating in ways to empower our people since time immemorial, whether it was creating ahupua'a systems and thinking about circular land management and industrial symbiosis in ways that we really cultivate and steward our aina, that aloha aina that everybody talks about, to creating the first color newspapers in the world, to having electricity in Iolani Palace well before the White House. This is what we do. So it's not strange for us to pick up new tools like genome editing, genome sequencing, deep learning, many new ways to think about the world and think about data broadly to really serve our communities. I'm from Mokuokeawe, specifically from Kohala area, and it's a really beautiful and complex place. Mokuokeawe is famous for its biodiversity, having 11 out of 13 biomes on planet Earth, some of the most diverse soil profiles in the world, you may know, but it also has a dark side. It's the extinction capital of the world, and it's the invasive species capital of the world. And if you did take a peek at the editorial piece that I had the pleasure of writing for Science, you would notice that I was pointing directly to mismanagement of land and the fact that Lahaina and Maui broadly is looking more like an African Serengeti than a tropical island in the Pacific. And that comes down to the introduction of a lot of invasive species. And we won't talk about this today, but there are many different ways to think about land management that could involve the recombination of indigenous Ike and Mana'o and new tools that are involved in land management, some of them in the synthetic biology space, for example. But you should also know that Mokuokeawe and Hawaii County is the most diverse county in Hawaii and in America, if you believe that Hawaii is part of America. And you can see that it is number one for being the most diverse place for human beings, followed by Maui County, which is number 2, Kauai, number 4, and Honolulu, number 11. So that's a lot of diversity when we think about the communities of people that make up what Hawaii is, right? All types of different communities that have come in different waves, literally, over thousands and thousands of years into more recent development with settler colonialism, and now what's going on in Hawaii in 2023 and into the future. It is the most diverse place in America, which means that we have extremely diverse genomes, which means that the way we think about precision medicine needs to be very different, and it needs to be tailor-made for the complexities of the communities that live in Hawaii. But when we look at the whole systematic approach of human genetic variation and who's doing sequencing and whose genomes are being sequenced and included in large-scale studies of human genetic variation, you can see that the lion's share of that data is biased towards one community of people, and that is individuals of Western European ancestry. And this is recent data from Melinda Mills' GWAS Diversity Finder. It's a really great tool if you're ever trying to think about these things. Now, the statistic that I think is even more concerning, though, is that 72% of genetic discoveries have taken place in 3 countries. So if we look at this heat map closely, you can see that the lion's share of these genomic studies are taking place in 3 countries. Ready? America, the UK, mostly the UK Biobank, and thirdly, Iceland. And when we think about the rest of the world is essentially outsourcing their mo'oku'auhau, their genealogy, their genetic material, to people that have the infrastructure established. So what does the infrastructure mean? Well, this is when we get into the supply chain issues. So the infrastructure probably means that you have a biobank where you can store things safely. It means that you have genome sequencing capacity. Maybe you have different platforms in which you're doing this. It means that you can store data and provide that data for others. Maybe you have a cluster of CPUs or GPUs, or you're using the Amazon cloud, or you have an infrastructure set up. But what that means for the rest of the world is they're actually outsourcing their biological material to places where there is infrastructure built. And I think we really have to think about that deeply. And we have to think about how valuable that information is today. So here are some statistics. If you'll look at this image, you can see that there are a whole bunch of patents on the wall. This is at Illumina's headquarters in La Jolla, California. And the reason I put this up, because this is a display of a collection of and creation of intellectual property. And to me, it's reminiscent of going to a hunting lodge and seeing a whole bunch of moose heads on the wall. That's kind of what it looks like to me. I don't know about you guys, but I think the numbers are really important. And if we look at the total number of patents that were filed worldwide that mention DNA sequencing or analysis as a significant application or method, and this is before the pandemic. So you have to think that there were a lot more patents that were filed after the pandemic, right? We're looking at 45,000 patents and individual pieces of intellectual property that have been filed. So I want you guys to think about what that means at that scale. And when we know that data itself is the most valuable commodity on planet Earth, surpassing oil in 2018, it becomes painfully obvious that collecting genome sequence data is very valuable. And it's very valuable, and it leads to these other forms of commodification, whether it's creating intellectual property or the sales of different types of pharmaceutical therapies that end up on the market. Some of them may become blockbuster drugs. And so when we make a comparison with data itself, including digital sequence information derived from human beings, we see that it's very valuable. And I, for one, mined genomic information for at least a decade before I ever connected the term mining, data mining, with what goes on with rare earth minerals, or actually getting to sites where we could extract oil. But making that comparison between a cobalt and data itself, right? Making the comparison with data as a resource is a really important philosophical shift that I think a lot of our communities have to go through. And if we take a look at probably one of the most broken supply chains in the world, does anybody know where this is? Can somebody chime in? What resource does this look like? Anyone?
Cobalt?
Cobalt. Who said that?
Oh, me. Oh, my name is Anna.
Anna, congratulations. Ho'omaikai. It is indeed cobalt. Cobalt. The lion's share of cobalt probably upwards of 75% of the world's cobalt is collected in the Democratic Republic of Congo along something called the Copper Belt. And what you're seeing here are a bunch of artisanal mines. You're seeing the extraction of cobalt. You're seeing no one wearing PPE. You're seeing this destroy their ecosystem, lead to long-term health problems. This is the most exploited and broken supply chain in the world. There's Tim Cook holding up an iPhone. The only reason we're able to have this conversation over Zoom is because there is cobalt in the integrated circuits and other components of your laptops and iPhones, etc. But what does this community in Congo have to show for it? Basically nothing. And so when we compare one of the most broken supply chains in the world to an emerging supply chain around digital sequence information that has been collected and extracted from individual geographically sequestered communities of people, namely indigenous communities, we don't want to recapitulate this power imbalance. We want to see our communities receive a larger piece of the pie. And so that is a theme for today's talk. Do you think that Tim Cook has ever visited the Congo? Look at these images. Of course not. We made these images using Midjourney. We deepfaked them in an attempt to put more pressure on large corporations to be in touch with the supply chains in which they are amassing their wealth. That's another thing we can do with different types of artificial intelligence and machine intelligence, is create images that potentially impact and create change. Okay, so that's an introduction into some of these ideas and contrasting the ways that we're creating new supply chains within the field of genome sequencing. And I'm going to tell you about 3 stories quickly. Hopefully I have enough time. The first one is going to be disrupting the ancient DNA supply chain. The second one will be disrupting the precision medicine supply chain. And then finally, I will take you on a futuristic journey of sorts, thinking about new tools and perspectives in the space of Indigenous data futures. All right, so the first project brings us to the Bishop Museum. Who's been to the Bishop Museum? I bet a number of you have. And if you got a chance to check out the exhibit, okay, awesome. Yeah, I figured it's an amazing place. Kind of grew up there myself. And if you want to check out this actual exhibit that we created called Regenerations Challenging Scientific Racism in Hawaii, it is available online to the best of my knowledge. And it was really fun. And it was an exhibit that we co-designed with our community, with multiple ohana from different islands in Hawaii. And the reason, and also, none of this would be possible without Jillian and Leah and the whole gang and our whole community that was involved in curating and setting up this whole thing. They're just tremendous people, super fun. This is on our opening day, and we were blessed with a nui nui, and it was a lovely day to bring and create community around these ideas. And what we were doing was building an exhibit around a collection of photographs that were collected because of eugenic science. There was a man by the name of Lewis Sullivan. Lewis Sullivan was taking in pictures of Hawaiian people who were of mixed ancestry, like me, and many people in Hawaii, because we have the highest percentage of mixed ancestry people in America as well. And they were trying to do different types of measurement-based studies on our kupuna, and it didn't go well. But we wanted to bring these experiments to the attention of our community through this exhibit, Regenerations. And we had to deal with a whole bunch of things that were going on. One, we had to communicate while COVID was reshaping the world. And that was really difficult. We did that over Zoom. We connected not only with our team, but with many different families in the construction of this project. And we iterated and co-designed with community. We had to do this in the face of white supremacy itself and what was happening at the Capitol on January 6th, and we're still dealing with the repercussions of that as a community and as a country. And we had to wrestle with the history of eugenic science itself. So this is an image from Cold Spring Harbor Labs in 1918, and this is one of their first annual eugenics research meetings. So the reason why I'm trying to make these contrasts is because we're doing a certain version of science right now in the space of precision medicine. Large-scale initiatives are happening all over the place. The Nobel Prize was just awarded in medicine for ancient genome sequencing technology development. And what we have to think about is what is going to be the legacy of these projects long-term? Because at one point in time, it was cool and encouraged to do eugenic research a century ago. And I didn't even know that when I spent time at Cold Spring Harbor as a student myself. I had no idea that that was the legacy of that institution. So sometimes it's really important to get institutions like the Bishop Museum to say, at what level were you complicit in this type of science? And can we have a reckoning with this? Can we look in the mirror and understand what the consequences of that type of science are, right? And so when we think about the anthropology of the past and the measurement theory of the past, right? Anthropometry, phrenology, measuring hair color, eye color, the contrasts and the similarities with the field of ancient genomics and genomics broadly today are not that different. We're using different tools to measure, but we have to not just ask questions about diversity, but it's who's doing the naming, who's in control of the data, whose questions are we pursuing, what is the agenda, what is the reason for this type of science? Because if it's the point of view of we are asking scientific questions because this is for the greater good, I'm sure if you're Native Hawaiian, you're asking, whose good are you talking about, right? Whose good are we prioritizing? And so we have to be very careful with the way we build these types of projects in the future because of what the legacy is here. When we talk about access to ancient remains, we have to ask questions about provenance. How and why did these remains end up in cold steel drawers, freezers, and boxes in attics and warehouses all over the world? Under what terms were they collected, right? You have to be very cautious and sensitive about building projects in this space. You also have to think about it, what it means when we're converting ancient remains from our ancestors, grinding them up into dust, extracting DNA, and sequencing the genome of that, because now it fits neatly into the digital surveillance economy. And that is a profound idea where we have to tread carefully around how we generate data in these spaces. Luckily for us, we got to work directly with our community members in building this exhibit, and we got to bring attention to many of these ideas. One of them is we created this torture table where we talked about a lot of these techniques and technologies that were used to create measurement data back in the day. We really want to bring attention to the 23andMe's of the world because of what they're doing, and direct-to-consumer companies that are happy to expound on your ancestry data based on a limited number of loci in the genome, but also in the same breath sell your data to large companies without really being transparent about that. So we wanted to bring that to the attention of many of our museum goers. But we were told by our legal staff that if we featured like a 23andMe, saliva kit, then they would have sued us. So we had to be creative. So we created our own company and we called it the Biocolonialism Trust. And here are a few of the products that we had just to bring attention to this. We said DNA in a box, trust us to tell you who you are, and many other things. We played around with the idea of consent. Consent is a really important idea as well. Under what circumstances are you having people sign over the rights to their genome? right? How comprehensive is that? What language is that consent in? If it's not dynamic, it's really problematic. If you consent something for a reason, and then new technologies come along that allow you to create a higher resolution look at the genome, you have to ask that question and say, do I actually have consent to move forward with that series of experiments? Is that what people signed off on? We also wanted to bring attention to these ideas around the ubiquity of genome sequencing, the decrease in the pricing, the fact that it has now become mobile, that point of care is a really interesting and important component. So here you see a mobile genome sequencer from ONT and a mobile PCR machine, and we're bringing attention to this issue that you could have a genome center in your backpack that you bring to some of the most remote places in the world. And even if that's possible, maybe the question is, do you have the right to do that? And under what circumstances? We also wanted to dial in and focus on some more futuristic ideas. For example, what was happening with genome editing embryos and the controversies that were happening in China, and bringing attention to these issues and saying this is very much a future. It's a future of fertility science. It's a future of the way that so many different people are focused on polygenic risk scores. There are a lot of different ways in which this could usher in a brave new world of health disparities. We need to be very careful about how we think about and prioritize questions in that space as well. But one of my favorite things that we featured was this lay that you see over here on the right. Does anyone know this lay? Anyone? Any of our guests? Oh, excellent. Oh my God. Do you know what it's made out of?
Hair, human whalebone.
Human hair and whalebone. Raja. That is correct. So because it contains human hair from our ancestors, it also is not just an artifact, it's an ancestor. And that means that it contains DNA, which can be extracted and sequenced. So when our ancestors' hair and remains are sold online to the highest bidder via Christie's and Sotheby's, that's extremely offensive, right? So when you see something like this pop up, that means that we, as scientists in this space who have knowledge about the kind of wild west of ancient genomics and how people are acquiring remains, that's our kuleana to bring attention to this issue. And one thing I'm very proud of and can say is that our one direct way in which we disrupted this ancient DNA supply chain is that by bringing attention to these issues and this lay itself as an ancestor, Sotheby's and Christie's does not feel comfortable selling our ancestors' remains online anymore. And this was a really effective way in which we used an art exhibit focusing on challenging scientific racism to actually have impact in spaces like online auctioning of maybe ancestral remains that they shouldn't have in the first place. So we're really proud of that. And that inspired a whole bunch of other ideas and focuses on safeguarding technologies, deterrent technologies, and counter technologies in the space of ancient genomics. That's why I put up this ADT sign. Who knows somebody's uncle that has an ADT sign but didn't pay for ADT? We all know somebody like that. But it's really important to create counter technologies and deterrent technologies in this space to safeguard access to this type of DNA. And with our team, we did that for MIT Solve a few years ago for their, I think it was called Indigenous Communities or Community Partnerships Fellowship. And one of the ideas we were thinking about is this idea of provenance and what types of technologies can we use to bring attention to the passage of these remains. They shouldn't be traded around like baseball cards. Their passage from one location to the other, provenance of them should be really controlled. And that's one of the things we wanted to do. So we brought attention to this idea around the Hope Diamond. The Hope Diamond, when it was originally cut into this beautiful flawless diamond weighed 115 carats. By the time it gets to the Smithsonian, it weighs 45. That's far less than half of its original size, mass, etc. This is exactly what's happening with a lot of ancient remains in museum settings. They're passed around from investigator to investigator. Bits of bone are shaved off, and nobody is creating and taking metadata. We don't know the whereabouts of a lot of our ancestral remains. So bringing attention to these issues and creating accountability and transparency in this space was extremely effective. And that's exactly what we did. Okay. Another interesting thing that's going on in the ancient genomics world now is that you have the capacity to sequence the genome of a Neanderthal, for example, in Spain, 1 meter away from the remains. So you can assemble a Neanderthal genome from soil itself. And that means that that soil is extremely valuable. And that means that that data is extremely valuable. And who is in control of all of that is very, very important. And that brings us to this much larger major issue around data sovereignty and data governance. And maybe many of you have heard of Indigenous data sovereignty or Indigenous data governance, but this is a big focus of a lot of the organizations that we're building all over the world. And we're very proud of this. And that kind of brings us to our second feature of this talk, which is the idea of disrupting the precision medicine supply chain. So let's kind of walk through some of these ideas. Many of you are familiar with All of Us project and the All of Us program, which their goal is to recruit 1 million people in the United States of America and oversample for underrepresented, historically marginalized communities like Native Hawaiians and African Americans and other indigenous communities from around America. But one of the kind of biggest issues with this is there's a massive collection of data, but what happens to the data and who has access to the data and under what circumstances and how that information is commoditized is not really fleshed out in terms of their data governance models. So if you look at a company like Regeneron, for example, the whole model of this company is to recruit individuals from geographically sequestered communities, whether they're African American or Amish, and they want to identify signatures of natural selection using various techniques like FST and more advanced statistical methods to identify regions of the genome that are under selection that might yield new intellectual property for the development of blockbuster drugs. Case in point, that's happening right now with all types of data sets. So when they're collected, we really have to think about what they're used for and what they're optimized for. Because sometimes what you end up with is you get drugs that hit the market that cost around $300,000. And you have to ask questions about how we arrived here in a healthcare system where genetic information that was procured through the Cystic Fibrosis Foundation, in this case, in the creation of Vertex, recruiting patients directly and then selling, using their genomes to refine the biomarkers that they use to create intellectual property and a blockbuster drug, and then selling it back to them for this price. And you have to ask yourself, is this a violation of the common rule? Is this what our healthcare system should be doing? Is this the type of science that we're supposed to be involved in? And I don't think that that really sits well with anyone, because I think one of the main goals here is utilizing precision medicine to create equitable opportunities for people to be able to take drugs like this to help them live their everyday lives. And that's not what's happening in this case. Now, when we look at another broken position in this supply chain, you have to look at 23andMe, who sold access to their database for $300 million to GlaxoSmithKline, followed up with Blackstone acquiring Ancestry.com for $4.7 billion with a capital B in 2020. So it's irrefutable that this information is extremely valuable and will yield long-term therapeutic intellectual property. So when we contrast that with what's going on with the All of Us program, we have to ask deeper questions about how and why those data sets are going to be taken over or driven over the goal line by large pharmaceutical companies, and why our communities aren't receiving a larger piece of the pie, or any piece of the pie, when it comes to the development of these large-scale screens of human genetic variation. Because these are the facts. Here, for example, non-Polynesian scientists filed a potential patent claim on a mutation that was discovered in the CREBRF gene in the 5th exon in Samoa. There were 0 Polynesian people included on the Google patent claim. This is a demonstration that these types of data that are collected from, really they're gifts of our diaspora and our position as being some of the greatest seafaring people in the world, from Samoa to Tahiti to Rapa Nui, Aotearoa, Hawaii, etc. This mutation is exclusively found in those places, and it is being commoditized. And so this is one of the major moments for me where I realized we need to get in pole position to protect our interests and our assets. So what does the future look like? Well, I can explain. The future involves vertical integration. So from my point of view, rather than attempting to innovate horizontally across existing institutions that have not shown a track record of really prioritizing Indigenous health and Indigenous data sovereignty and governance, we personally have decided to vertically integrate and innovate. And this is the same thing that Henry Ford did when he was creating the Model T. He bought thousands of acres of land to grow rubber trees in the Amazon. He was in control of every component that went into the development of the Model T. And this revolutionized transportation, from ball bearings to leather to tires. This was an extremely effective technique. So from one Amazon to the other, that's exactly what Amazon.com is doing. They know that their web services, as a web service and cloud provider, this is their most effective cash cow. That is being a steward of your data, holding your data, and sort of being a broker for the most impactful and powerful resource on planet Earth. Knowing that, and knowing what vertical integration means in the space of Indigenous genomics, we built the Native Biodata Consortium, research for natives by natives, and we vertically integrated everything from our biobank to our servers on Indigenous land in Cheyenne River, the first of its kind on a reservation in U.S. history. And it has been extremely effective. And we have all types of projects and things that we have going on. And one of them is the development of our own edge computing and cloud computation services, so that we can provide a safe location for our Indigenous partners to store their data and information. That is, if they don't want to work with the Amazon Web Services, the Google Clouds, or the Microsofts of the world. We're also thinking about clever ways to create transparency with our inventory. Most of you think about blockchain as a way to launder money, or FTX, or Sam Bankman-Fried, or crypto. But the reality is that these algorithms are really cool and fun ways to think about provenance, decentralization, and transparency. And that's a paper that we published in Cell last year. We're also thinking about federated approaches of masking certain parts of data sets, sharing other parts of data sets, and taking federated approaches to the way we process, store, and protect data and information. That's another paper we published in collaboration with Hugging Face AI in Nature Machine Intelligence. You guys are welcome to check that one out. And popularizing and bringing attention to major ideas around benefit sharing itself. This is the idea that you would give percentages of proceeds that are derived from intellectual property, from genomic information that is derived from many of our communities, and this is a piece I published in New England Journal of Medicine, kind of reacting to the sloppy way in which the All of Us program in the National Institutes of Health was addressing security concerns around our community's information. And benefit sharing is taking off. It's becoming ubiquitous in many different spaces in which people want to think about and care about data governance. And it's not a new idea. This is an ancient idea. Here are a whole bunch of fish that we caught just on a pot of that. And we don't just stuff our freezers. We give these fish to people who need them in our community. So why wouldn't you do that with genetic information that you're deriving, that you're sequencing, using taxpayers' dollars to do that? It just makes sense. It's just a more equitable path forward. And that's how and why the companies like Variant Bio exist, because Variant Bio is founded on the idea of benefit sharing and working exclusively with and partnering with Indigenous communities and giving them not just equity and ownership of their data and 4% of the proceeds and revenue that come from the development of therapeutics in this space, but also free access to any drugs that come out of that pipeline. So that's particularly disruptive to the existing pipeline. You know, in the end, there's no substitute for attention to detail around building consensus, grassroots research, democratizing technology, and allowing communities of people that have not used specific types of technology to begin to dream, imagine, and be creative with these new techniques, technologies, and tools. And here are just some of them that we're thinking about in the point of care space, working in a number of different places. Mobile genome sequencing, we talked about that in many of these different tools, mobile ultrasound, etc. These are great ways to de-black box how a lot of these technologies and tools works. Here's a big scout study that we are wrapping up in a number of different places in Moorea and Tahiti. And these are just some of the mobile tools that we were using in that space. We're also thinking about decentralizing access to sequencing and biotechnology workflows themselves. So is BioNTech, so is Moderna. These are opportunities to eliminate the cold chain and decentralize production of mRNA vaccines. And these are the types of ideas that we should be thinking about in some of the most remote places in the world, reimagining what access to laboratories looks like. Why are we shipping our community's DNA to places like California when we should be doing all of the sequencing on site at places like Queens, where we have been serving the Native Hawaiian community since 1859? And these are just some concepts and ideas around those sorts of things. Okay. All right. I guess I'll stop here and I will take everybody's questions, but thank you guys so much.
All right, let's give a big round of applause to Dr. Fox. That was a wonderful talk. I have several questions, but I don't want to steal other people's time. So please ask some questions.
Thank you guys so much too. Anybody?
I guess
have a
if
question.
nobody, oh, go ahead, Anana.
Sorry, Edo. So I was wondering if you have any thoughts about how the concept of Indigenous data governance changes when we are not talking about genomic data. So a lot of us on the call work with medical imaging, for example.
Great question. I think I mean, what is data in the end other than a series of observations? So I think it definitely falls into the purview of that. I got to lead a whole expedition for OET Nautilus, and we were having debates around everything from underwater photogrammetry data from archaeological sites to microplastics to, so I mean, I think it definitely falls into that category. Again, imaging data. I also want to just create like something I think that's really important to, like, genome sequence data by itself it's powerful, but it's nothing compared to the way that when it's aligned with phenotype data, whether that's, I don't know, standard biomarkers. But when we get into the mix and we're talking about true potential for prediction and prevention and aligning genome sequence data or real-time genome sequence data with high resolution imaging data, MRI, and things like this, I think that is going to be really, really cool. And I think it's happening in a lot of different places. So I don't want the conversation around data governance in a lot of ways to get in the way of what the potential actual medical impact of an alignment of two data sets are. But I think that more patients should be aware of how important and valuable this information is. And I don't think they are. I don't think that clinicians, not to just pick on clinicians, I'm saying, or us as, whatever card-carrying scientists, have not done a good enough job of explaining how valuable this information is, right? So, but good question. Yeah.
Can I ask a question regarding Iceland? Because Iceland,
sure.
I believe, is one of the first examples in which use of genomic data of a sequestered population tried to take advantage of that concept. Do you see that as a model? Do you think that is a good way of dealing with it? What was the success, or what are the pitfalls that they ran into? Can you elaborate a little bit on that?
Yeah, that's a good question. Good to see you. So, okay, Iceland, I think they have around 600,000 people, if I'm not mistaken. Could somebody Google that? See if I'm right. So it's not terribly big, but wherever you have geographically sequestered communities of people, you're going to find interesting signatures of natural selection. So if it's, island communities where you're accumulating bottlenecks, if it's the impact of European colonialism itself on the immune system, if it's high elevation adaptation, you're going to find interesting things, right? There was a tremendous paper that came out looking at SLE, lupus, autoimmune disorders in Iceland. They have some of the highest rates of this in the world. And they were able to piece together these beautiful pedigrees using exome sequencing in ways that no other part of the world really did this. And I think this is another shortcoming of large scale, million people. It's like, do you guys want a cup of Starbucks, which is not good coffee, but they can churn out 1 million cups of it a day? Or do you want really high-end artisanal, high quality approaches to things? And I think that's what individual patients need. And I think there needs to be more of an attention to detail around the trend. Higher resolution genomes coupled with high resolution phenotype data in really beautiful pedigrees where we can understand the transmission of rare variation. And I think like somewhere like Iceland, they know what the playbook is. They also have Decode there and Carrie Stephenson, and I think they're doing a good job. I don't know what the people want. I've never been there. I'd love to go there. I know they're particularly innovative in other spaces like geothermal energy and other things. So I don't see why not, but I was impressed by that lupus paper. Yeah.
Hi, what really wonderful talk. I want to get your perspective on, particularly for many Indigenous populations, use number of ancestors within that community to identify access to community resources and leadership. So I was curious about your perspective on how genetic determinism of identity versus individual lived experience and generational lived experience figure into Indigenous futurism, particularly given the impact of colonialism on specifically island communities, and that, expected admixture over time?
Okay, lot to unpack there.
Yeah, it's a big question. So
yeah. Okay, so you're saying, like, in terms of people's identities. So, I mean, if you want me to be frank about that, I feel like the United States government has used things like blood quantum to separate our community from assets and resources since its inception. So at one point, if you had one drop of African blood, you couldn't vote, right? Because you were a fifth of a human being, even though you only had one. But what is that? That's a control mechanism, right? That is systematic and institutionalized racism and eugenic science. Okay, so now let's go to the Homestead Act of 1921. So for our community, if you don't have 50% blood quantum, we can't have access to land that was stolen from us. Let's be real here, and I'm just keeping it real because I'm a Hawaiian person, and I know that 1% of my community owns land in Hawaii. And we should all think about what that means. You should think about what it means when we have poor decision-making around land management and the diversion of water, the deployment of guinea grasses and kikuyu grasses, more golf courses, more resorts, and my people are living in tents and Waianae. Like, what's going on here? How did we get here? And how do we reimagine a more equitable Hawaii and a way to dig ourselves out? That's what I'm about.
Yeah.
So
I guess the extension then is for the future generations that may not necessarily meet that a very strict blood quantum for access to community leadership, that they should have a voice in some of these considerations of, use of, data more generally. Here we speak genetic data, but just general.
I totally agree with that. I have no problem with that. I think that's very much the future. The other side of the story are the types of policies that are created to separate our community from power and influence. I think that's the more, we need new solutions in that space. But yeah, I think it's a good question. And if it makes you feel uncomfortable, good. You know what I mean? We have to have those conversations.
May I ask another question? So
Please.
if compartmentalization of genomic data or proteomic data or data in general is abundantly implemented due to the ideas that you put forward, would that put it into a danger of what we are facing now in medicine, which are orphan diseases, which if you don't have enough financial incentive to get into it, would that lead to kind of neglecting these smaller minority genomic data sets? I don't know.
Yeah. It's a good question. I think, like, if we were to audit the way we even do clinical trials and we look at the amount of diversity that exists there, it's like we have this small is beautiful thing, like the Martine Rothblatt model, where it's like you can recruit 7 people into a clinical trial for Kabuki syndrome, and that's okay, and that's approved, and that's above board, right? But then every other clinical trial is 95% individuals of Western European ancestry. I think we need to find new ways to incentivize diversity in clinical trials. We're writing a new paper about that too. But I think benefit sharing is a huge path forward. Like what we've done with Variant Bio, I just want to be very clear. It's like, by giving people the opportunity to build infrastructure locally, it's like, we want to help you create a sequencing center, infrastructure for a biobank, servers so you can process and store data. We want to help you build a trust so that you can use information that's derived from your genome And why is that diversity there? Well, because it is a reflection of that specific place over time. And you will be able to use proceeds from the development of therapies that are going to impact your people to buy back your land. Like, show me another circular system that's as cool as that in Big Pharma. There's nothing. So we're very proud of that. But I think we need more innovation at that scale. You know? Yeah.
I have a quick question. Hello, Keolu, it's good to see you. I think we should have you come out to Hawaii so you can see what we're doing on the ground. A lot of our communities are still in those situations that you mentioned earlier. But you'd be surprised by some of the positive responses that we've had in terms of participation in a lot of the research on health disparities that include information that, of genetics, but also other factors that, of course, contribute to the health conditions. And, you know, there's a real strong rally for trying to increase the representation of our communities in those types of studies, because as you know, obviously, we need to be represented to be at the table to really understand how do we contribute, you know, address these problems and contextualize it from a community perspective and include measures of resilience, not just adversities that are actually coming from the community, which I think is really key in trying to not only increase the participation, but then, of course, address the issues. One question I had for you was, so, you know, given the fact that, you know, most of these genetic differences in these polymorphisms obviously don't work in a silo, they don't work independently. They often are actually pretty rare in terms of accounting for a specific trait, right? And so majority of, you know, the cases involve like the observable traits that you see in the phenotypes are linked through not just the genetic differences, but on top of environmental factors and other conditions that work in, you know, developmental conditions, right? And on top of complicated by what we talked about, admixture. So I understand the need to really take back our own sort of knowledge and use that for improving our health and integrating it with methodologies that, you know, are valid scientifically, but also can be more expansive. But I'm a little confused on how you would separate sort of the identifying specific genetic variability that might have assigned a particular risk to for a particular disease, but then it really needs to be the way that you would express that outcome would be with environmental factors and other things that are, you know, contributing to that onset. So I'm a little confused how you would separate sort of the findings from genetic variability and assign that as and assign it in you know, this close economic circle that you mentioned, and, you know, to provide the sort of the financial support back to communities. How would you separate, you know, the variability that's at the genetic level from the environmental factors that then trigger the outcome in terms of manifesting that condition? You know, you understand what I'm trying to say? It's not just a specific polymorphism, but how do you track it with the actual, you know, observable outcomes?
Yeah, that's a really good point. I completely agree with you. I think it's like a really complicated, dialectically intertwined system. I think, like, so far as the promises of precision medicine and what we've been promising as a field for decades, since prior to 2001 and Craig Venter guys and all that, I don't think we have had a significant impact in thinking about common complex disease at all, like heart disease, cancer, type 2 diabetes.
Yeah, I agree. And I think we've realized that it's not just, you know, genetic variability. There's a lot more complex data sets that we need to understand comprehensively how the disease manifests, right? So that's the question I have, is like, it's, you know, genetics is one layer, and actually even just looking at polymorphism, particularly across different populations, that it's also a distinct layer, right? Because it's, you know, it depends on what field, like whether it's pharmacogenomics, whether a specific protein is interacting with that particular gene, how is it going to be expressed? I mean, there's a lot of, at that level, at the molecular level, there's just, it's hard for me to understand how you would separate. Well, you can't separate that necessarily from the other levels of data that you would need in order to understand the sort of comprehensively understand, you know, disease outcomes and how those factors might be influencing individual conditions from, you know, a variety of different responses and, you know, compensatory mechanisms and epistatic effects. And, you know, there's so many, it's multi-leveled. So I think in the data sovereignty, I think it's really interesting that, you know, with a focus on genetics, but then you would have to broaden that up to add the many different layers of data that's needed in order to contextualize that information, that genetic information, and then to actually have a translational value or an applied value for medicine or for risk assessment or for anything, like, you know, personalized nutrition, any of those types of outcomes that you'd like to see. It's a much more complicated and more nuanced area. So that's why I was asking about this, you know, like how can you separate just the genetic variability and, you know, the identifying those from, you know, specific populations that might contribute to, you know, disease conditions, but then it has to be in the context of the, you know, these multi-level data sets that really make the difference.
I think so. I think so far as like minority health is concerned, I think you and I both know that our community would be a lot healthier if we owned our own land, and that a lot of, I don't want to say like a lot of these large scale government initiatives are just, I think they're really ambitious and interesting, but when it actually comes down to impact on our community's health, it's a big old goose egg. So we've gone in a different approach. And you know, definitely building the complexity of data sets, layering them. But in the case of what is actually commodifiable and who's going to be doing that, all of us has nothing to show. You can look at the whole public record in New England Journal of Medicine. If this is a boxing match, I'm like the lineal champ, you know, and there has been very little feedback or reciprocity in that space, and I think that's the biggest problem.
Well, I agree with that. That's for sure, and that has to change. But no, there are alternatives to that, and I think that's what we're working on addressing. And so that's a good that, you know, we're, I think, in that sense, taking the steps needed, really rallying our communities that that need to understand, you know, exactly what your point's about in terms of the deficiencies in knowledge and what this information can achieve, what's the limitations of these, you know, types of tools and technologies, and also like what are the potential benefits. Oh, John, sorry, I interrupted you. Go ahead.
Alika, you mean you didn't interrupt me? I was just had my hand up to ask a question when you're finished.
Oh yeah, sorry.
Are you finished? Okay. Thanks for your comments. And Dr. Fox, thanks for being with us. I'm a researcher at UH Cancer Center, and I would like to better understand your vision of what you would like to see 20 years from now. What would the landscape look like? Because if I can just for feedback to understand better, it sounds like you would like us all to have personal control of our genome in such a way to where we could make intelligent decisions of how it's used, but potentially only give rights for particular uses. And if something is, and we're compensated for that. And if there's something that is found to be economically viable, there would be a pathway back to the individual. So you mentioned blockchains, and I'm kind of imagining like the automated contracting that's done with Ethereum, so that you can, all this can happen in the background and be tied to, you know, controllable mechanisms. But can you elaborate on that a little bit? Because that's what I think you're saying, but I would like to understand better.
Yeah, absolutely. That level of transparency, like any development in, I think that's a really good thought experiment, by the way, is being like, in 20 years, what do you think? You know, I'm hoping, yes, very much so. I think like right now, the way things get funneled in and again, driven over the goal line by the Regenerons of the world is not really helping us. And then making space, like I love that pathway of transparency with digital ledger systems and smart contracts and that sort of thing, right? And then there's the fact that, like, just to pick on all of us, there was never any moment where all of us said, hey, I want to get all the representatives for every single Indigenous community in this country. Let's have a summit. Let's have a meeting and discuss what this is going to look like. It was all of you people are lumped into one category. That's Indigenous people. We don't care what your diaspora is or experience with colonialism or what your level of distrust is in biomedical research. Like, basically, the train is leaving, get on the train, right? And I think that our communities deserve something that Miley Arvin refers to as regenerative refusal. So that is, I don't have to get on your coal-powered train. I can wait to build a speedy Shinkansen and just zip right by you. I can do that. We have the right to do that. And so when you think about scale and decentralization, it's like when you centralize all of these assets in Palo Alto, Cambridge, and the other Cambridge, whatever, that's not really helping our cause. That's distributing our resources to those places. So in 20 years, I'm hoping that all of our communities have representation, infrastructure, and we've trained the next generation of people to be literate and fluent in how to utilize that information so that it actually results in, you know, any standard metric of progress in terms of health, infant mortality rates, et cetera. But I've just, you know, having been in genomics for the last decade, I just am not seeing the impact that I thought I would. I am seeing the impact in big pharma. You know, I am, right? I'm just, you know, not to be cynical, I'm just saying these are the facts, right? But in the next 20 years, I'd like to see, yeah, way more control. Yes. Someone else has their hand up.
Yeah, thank you so much. And I want to be respectful of your time, knowing that we're like 15 minutes over time. Is it all right if I ask a question?
Absolutely.
Okay, well, thank you. So I'm thinking about how can we reconcile things like sample ownership and protection of someone's genomic data when we can access genomic data out in the environment through things like wastewater, you know. How do we protect that data set, and how do we protect that integrity of that data set when it's able to be accessed elsewhere and it's something that we can get from the environment, but we want to make sure that we're protecting this data set for Indigenous communities, minority communities?
A good question. So funny you should say that. We have a big review coming out in Nature, I think it's Genetics or Nature Microbiology, but it's all about microbiome, IP, and Indigenous ownership. And so that'll be, and I'm happy to, that has a way more comprehensive kind of breakdown of a lot of these things, you know, and I think it's really important. And I honestly look at that space as a whole nother kind of gnarly, yeah, but I hope that's helpful. Yeah, I'll send it.
Yeah, be on the lookout for that paper. Yeah, thank you.
But Professor Shepard, I love the whole, I love the idea of making that consensus process smooth and ubiquitous, and, you know, like.
Well, I struggle with it because, for example, if individuals have control, then the decision-making of a community is weakened, right? You can't, as a community, make a decision on how you would like your ancestral genome used, because we're all branches of a tree, right? And so if there's 50 people that are offered more money, you know, as the price of the genome goes up, then the cohesion of a community starts to fall apart. It potentially, such that it's difficult. If everyone has control over their own genome, then the Indigenous grouping decision making seems to be weakened, and I'm curious what your thoughts are on that.
Yeah, it's a good question. So with Variant Bio, we have two of these kind of consensus building mechanisms and benefit sharing kind of directions. One of them is this kind of individual, kind of like stakeholder, shareholder ownership model, right? But we all know that like different people's genomes are going to have different, each of us have, I think, something like 10 private mutations in coding regions, for example, right? That's like from Daniel MacArthur, I think, back in Science 2010 or something, right? Whatever. But okay, so how valuable is that information at scale? This is probably pretty valuable, but then we have a collective trust and collective interest and trust model, which is I based a lot of that after the trusts that we've built in Hawaii, right? And I think that's a way more cohesive way to go about things. Like you can't lobby other people. I mean, you could at some level, right? But you can't influence people's decision-making processes in terms of like corruption, cronyism, etc. in the same way if you have like individual stakeholders. So there that's kind of one model. And then you could have this whole kind of Voltron perspective. I don't know if you guys remember that cartoon show where it's like, it's not Voltron unless they're all together. So if everyone doesn't vote on something and you don't reach consensus at a specific cutoff, then it doesn't count. So it's more like a citizen assembly sort of approach, which is like big in Europe. But and I want to just like challenge everybody too. It's like I think it's important to popularize these ideas as disruptive to the status quo and like have everyone questioning like how important it is for us to all come to this consensus as individuals and not just accept things and be like, okay, business as usual. This is how healthcare should be in this country. You know, like, man, it's broken, or it was designed that way, but it's not working for us. And all of these new technologies and approaches come together in ways that I think really could be serving people, all people, not just historically marginalized, like all people, right? But if we just accept the status quo and we're like, this is cool, got my paycheck, I'm happy, I'm gonna go surf today, whatever, then that's what you get, so.
I think that's interesting, Keolu. I think most of our community understand that the system is broken. I think where we find a lot of variability is trying to understand how it can be fixed or resolved. What's the alternative? And even within our own community, as you know, it's very diverse, not only admixture-wise and genetically, but also in perspectives and opportunities and experiences. So that's why I wonder, about building that consensus, especially we're trying to understand sort of indigeneity, what that means, what that looks like in that 20-year time frame that John mentioned. How do you do that, especially without a governing agency or any semblance of sort of unification within the population, similar to what other tribal entities in the mainland have, where at least the federally recognized tribes have some sort of independent governance or some structure around it that sort of provides a mechanism for determining consensus and action as a unit, where in Hawaii, as you know, we don't really have that type of organization or support.
Yeah, I have a lot of ideas on that, actually, like from the but I share your frustrations, Bada. Like, that's just how. But I think few things though that I will put into context. I mean, one, I think that the whole healthcare system always puts Oahu first, and that's I think it's really frustrating for people from the outer islands. And I think that I don't know. I think we have like major problems that are much larger than genomics. I hate to say it. It's become obvious to me. I think, yeah, but in terms of how we build consensus, I don't know, but I'm happy to talk to you about that offline, as Kanaka Maoli.
Sure.
I can
Okay,
ask
well,
some. Yeah, Yoshi, yes, Yoshi. Thank you, thank you. Yeah, thank you very much for your valuable information. I agree with you. You think the genomics or genetics is very important, right? For human health, you say the precision medicine. There are so many successful stories, right? So we just one example, like for example, EGFR receptor mutation, you can specific drug. So even the company, the pharmaceutical company benefit a lot, but also those patients also benefit, right? So I think it's very important. So so if we whether indigenous people want to use this drug, you need to know those genetic information clearly because it's a target therapy, right? Give another example, like immunotherapy. Immunotherapy, the best biomarker is the tumor mutation burden. You must do a sequence to know the tumor mutation. If you don't do it, you don't know whether this patient can be used. So those information, why we get those target, why we go to those biomarker, because those European people, ancestor people, they really gave the contribution. They are benefit the whole world. So also, I think our people also want to benefit ourselves, also want to benefit the world. We want to contribute to the world too, right? I believe. I also believe agree with you what you said. We're building our local infrastructure. I think that's a very good way to do it. Yeah. So then this way can let us have more close communication with the local indigenous people. Another way can build more trust. I agree with your opinion. Thank you. Very good talk. Yeah.
Thank you. I agree with you about the immunotherapy stuff, but check this paper out, sir. Hold on. I'm gonna throw it in here for you. I personally believe that there's so much diversity in places like Hawaii. This is where we should be doing clinical trials. It's like when people in finance are like, if you can make money in New York, you can do it anywhere. It's like, well, why don't you go to the most difficult tapestry of genetic information that exists, which is a place that's extremely diverse, and then show us that your drugs have efficacy instead of, so that's kind of one thing I was thinking about with just any new form of, CAR T or anything like that, Yeah.
Hi, Keolu. Sorry if I can ask just one question. What kind of safeguards do you foresee put in place, or you would like put in place to protect patients' genomics data, knowing that it's a multi-level issue, trying to balance diversifying the clinical trials, but also protecting people, bringing in therapeutics that would work in them, not assuming that what worked in 90% white race patients or participants would work in any other ethnic groups. And also there's funding issues. Pharma get the big piece of pie because they're able to fund those studies. They're able to mine the data and collect all the information. No academic institution, no hospital can do that on their own. So how do you see that balance, and what kind of safeguards do you want to see put in place to address that issue?
It's a really good question. One is just in terms of like, if you think about who has water catchment at their hale, anybody? We do. And if Amazon Web Services is the largest water catchment for data on planet Earth, which it is, then why wouldn't we decentralize water catchment systems, right? So I would like to see more Alikas and people that are, or Leah Dowsets, or people that are from our communities that have achieved the highest level of education in major decision-making positions. I'm just speaking to Hawaii, but you could, take this playbook to Navajo Nation or, Standing Rock or wherever. So that means more Hawaiian people in positions of leadership making decisions about these types of issues. I think that is inevitably going to lead to safeguarding in a lot of cases. The Then it's the actual hardware aspect of like building out the capacity, you know, physically. Yeah, I think that's a really, really important thing. And, you know, dare I say it, more entrepreneurial spirit on account of like, you know, the purple Mayas, like how many indigenous led pharmaceutical companies are there besides Variant Bio? Like, show me. None. So that shows you what we're dealing with in terms of that ecosystem. And then from the data scientist point of view, it's like, how many indigenous coding languages are there, scripting languages? Does anyone know? So it's like we're having this conversation in English. When we're coding, a lot of people are using what, like Python? What else? Anyone? Can anyone think of an indigenous one?
I can't think of any except English.
Yeah. So R was created by Ross Ihaka. He's Maori. So I'm just pointing you in the direction of being like, oh, the physical infrastructure of the way we create bias and safeguard or protect our assets. I mean, we like, what mediums are we creating science in? From the basic level of scripting languages all the way to the foundation of startups and larger companies. Because like I thought when all of us money was allocated that it was not a good decision to centralize a giant study when you could have divided up those billions of dollars into like smaller basic science questions. I just feel like that's a much, much, much better approach, you know? Like, have you guys ever heard about that story about the teacups? Somebody told me this. This is so cool. So there's two groups of people, 50 people in each group. And one group of people, they tell them, you need to make one teacup and it has to be perfect. Okay. And then the other group of people, they're just like, hey, go ahead and just go nuts. Go make as many teacups as possible. Put them in the kiln. Who do you think achieved a perfect teacup faster? The group with where they said go nuts, because people, right? It's iteration. You're iteratively working your way through things. So if you establish $5 billion for a giant study of human genetic variation, well, who's going to move into the pole positions of leadership? Do you think it's going to be assistant professors like me and Peter? No, it's going to be people that already have an established track record. And a lot of it is like, you know, business as usual. And then they'll make big consortia and people will be less creative about the ideas that they put out into the world. And it literally is a proven track record for less innovation. Mm-hmm. And, you know, so we're not just mad because they, you know, are, you know, there's logic on my, I think, I don't know. But.
Okay, well, thank you for joining us, Dr. Fox. That was so fantastic and loved your presentation, and thanks for being generous with your time to answer so many questions. We hope to see you in Hawaii.
Yeah, John, can I just say something for a second?
Sure.
Keolu, I would love it next time you're in Oahu to go by and meet John and his whole team. They're fantastic, and you all would get along so well. And they're all on this call, so now they've met you on the call. But we talked about this on our last conversation. They're really kindred spirits, and I really would love it if you could meet them in person.
I would love that. Maybe we can all have a meal and go cruise and just kind of think big, you know.
And you know, yeah, and they do think big there. And you know, Keanu, right in front of their door that they all walk in every day is that beautiful, huge vortex sculpture with the stones, and it has 8 eyes on it because it's trying to remind everyone in the cancer center to think about things from many different perspectives. And that's exactly what you do. So you're sort of like the personification of the thoughts that went into that statue. So I'd love it if they could meet you in person. John, you guys are really kindred spirits. So I think it would be great to meet in person.
Love that.
Yeah.
It's all good.
And my daughter and son-in-law are in San Diego. So if next time I'm there, I'll stop by.
Yeah, you should. You should. I'd love to show you some of our new spaces and stuff. And who's gonna go to the PSB? Anybody? I know Peter will.
I'll know in September. We're waiting for the results.
Oh, okay.
I would like to go.
Yeah. Okay, cool.
So, Keolu, can I always write a recap after everyone speaks to our group. Is it okay if I use some of your slides in my recap?
Oh yeah. Have at it. You know, all public information.
Because there were a lot, sometimes we have people from all around the world, like from the Middle East and Asia on this call. And we had a lot of people today. I think we had like 95 people on the call, but a lot of my friends couldn't join because of the time, but a lot of people wanted to hear this talk. So I'll share a recap with everyone.
Okay, great.
Okay.
Well, thank you again. And look forward to seeing everybody at our next call in October.
Thanks so much.
Bye-bye.
Mahalo nui for the opportunity and enjoy your weekend.
Happy aloha.
All right.
Bye-bye.